Hello, my name is Tuan, and I'll be showing you how to do problem 10.42 for Mastering Physics homework number 5. So in this problem, it says there is an ice cube that weighs 60 grams. It is moving up a frictionless slope of 30 degrees, and at the bottom there is a spring with a spring constant of 30 newton meters, and it is compressed by 10 centimeters. It is asking how high will the cube travel after it is launched by the spring. So basically, you're finding the maximum height that the cube reach after it is launched by the spring. To figure this out, you need to figure out where the energy will start and where the energy will end up as. I figured the energy will start with the spring because you're using the spring to push the ice cube upward. Once the ice cube reaches its maximum height, the energy will convert into gravitational energy because at the maximum height, nothing else is affecting the movement of the ice cube beside gravitational energy. So what you can do is you can set spring energy equal to gravitational energy in order to find the height from the gravitational energy formula. So this is the equation for spring constant energy. It is 1/2 times spring constant, multiply that by spring displacement. Once you figure this out, you can substitute that into Eg and divide by mass and gravity in order to find height. Separate the height from mass and gravity by dividing it. Before I did the problem, I converted my units into from gram and centimeters into kilogram and meters because the unit that we use for energy is joules, and joules has kilogram and meters instead of grams and centimeters. It'll be much more important later on in the unit, but when I did it without converting it, it still works. Um, so let's find the total energy from the spring. We can substitute in spring constant and spring displacement using this, which is 30 newton meters multiplied by 0.1 meters, multiply that by half. When you solved it, it should be 1.5 joules, and this is the total energy in the system. Now that we find the total energy in the system, we can substitute it into the gravitational energy formula as 1.5 joules multiply equal to 0.06 kilometer, which is the weight of the cube, and then multiply that by 9.8 meter per second square, which is gravitational pull downward. And then you have to multiply these two out, which is equal to 0.588 kilometer multiplied by meter per second square. And then you can divide this number by 1.5 in order to find the total height of the cube travel upward. In this case, it will be 26 centimeters. For your problem, it might be different because you have different number. But this problem should make sense, or this answer should make sense because 1.5 joule is not a lot of energy, and so pushing an ice cube, a 60-gram ice cube upward, should not be super high or super small. So 26 centimeters seems like a perfect number. I hope this helped.